Hello, grade 12 STEM students. Welcome again to our fifth explanation for the LAS number 5 entitled Common Isotopes and Their Uses. So this is just a run through of the learning activity sheet provided by the Schools Division of Batangas for General Chemistry 1. Okay, so just a discussion about some of the information for learners about isotopes and some of the activities that require you some computation. Paano ba gawin ng mga ito? Yung mga activities na nangangailangan ng additional information for this learning activity sheet. Starting off with isotopes. Okay? Ano ba yung konsepto natin ng isotope? And what are isotopes? Isotopes are atoms of the same element that have the same number of protons but different number of neutrons. It's very clear, class, that isotopes are just the same elements or atoms, only that the number of protons and the number of neutrons here will be our focus. Same ang protons, different ang number of neutrons. Ano ba yung tinatawag nating protons? The protons are the positively charged particles. Let's focus on that. When we say protons, these are positively charged particles, and it's denoted by P+. So let's say it's P+. That means the protons are positively charged particles found inside the nucleus of an atom. The neutrons, on the other hand, are subatomic particles that have no charge. So usually we denote it with NO or N0. Okay, that means there is no charge for neutrons, and these are also found in the nucleus of an atom. The protons plus the neutrons gives you what we call the mass number. So the mass of an atom depends on the number of protons plus the number of neutrons. Some call this atomic mass. Now, another subatomic particle is called the electrons, and these have electronegativity, and this gives you the negatively charged particles. Okay, so we denote this by the symbol E-. So electrons are negatively charged particles, protons are positively charged particles, while neutrons are particles with no charge. Protons and neutrons comprise the mass number or the atomic mass, and they are found inside the nucleus of an atom. Okay, different isotopes exhibit nearly identical chemical behaviors. Ano ba example ng isotope? Let's say isotopes of oxygen. The isotopes of oxygen have 8 neutrons inside the nucleus. One with 9 and the other with 10 neutrons. The most common oxygen is having 8 neutrons, but there are also 9 and 10 oxygen atoms with different number of neutrons. So they are called isotopes. If you're going to look at the isotopes of oxygen, they will all have the same number of protons. The number of protons of oxygen is actually 8. So there are 8 protons, and there are also 8 neutrons, or 8 protons and 9 neutrons, 8 protons and 10 neutrons for the 3 different isotopes of oxygen. So what is the effect of the different number of neutrons in the isotopes of an element? So different isotopes exhibit nearly identical chemical behaviors, but their physical properties like mass, melting point, density, and freezing point are all different. So yung isang pagkakaiba lang ng neutrons nila, some of the physical properties like the mass, melting point, density, and freezing point will be different for different isotopes. This gives you the list of some common isotopes and their uses. Just try to read through them. The most common that you can hear is about cobalt-60 and the carbon-14. Cobalt-60 destroys bacteria in food, the gamma ray radiation for tumors, and carbon-14 is used for carbon dating or finding the age of fossils and artifacts. You can also hear that in Araling Panlipunan. So these are just some of the common isotopes. and their uses. Okay, try to read all of them. Now, for this case, you have a problem solving which involves getting the average atomic mass of the isotopes. So, here you have the europium having two isotopes with a mass of 151 and 153. The given also is the percent of abundance of the two different isotopes. One is 48.03 and the other is 51.97. So, ano ba yung percent abundance? So, ganun sila karami in nature. Or in nature, yan yung pinaka nagsasabi kung ilan ang 151, approximately anong percentage ang 151 na europium, and naturally, ilan ang percent ng abundance ng 153 europium. So, let's try to solve for this example. Okay, so in this case, you have 151 and 153 and the percent abundance. To solve this, we have to use a calculator. Okay, so we can easily compute for the average atomic mass. Now, remember that if you are given percent, you have to change it into decimal numbers. Now, let's try to solve given the example. Okay, we have 151.48.03. So, using our computation, you can see that 48.03 will now become 0.4803. To change the percent into decimal, you have to divide it by 100 or move the decimal point 2 places to the left. Multiply that by 151. Okay. Then, add that to the percent abundance of 153, which is 51.97. You can do 0.5197. Multiply it to 153. And then, you add it together. You can use your scientific calculator. And that gives you 0.4803 times 151 plus 0.5197 times 153. That gives you 152.0394. That number is called the average atomic mass of europium. Okay, so that's how we solve for the average. Moving on with our examples. So this is done for the problem solving. That's just an introduction to that. Okay, so for the activities for day one, so this is just a very easy activity. Look me in the eyes. So we can just do it. Let's move on to activity number 2. This is just a pretest, just answer, and you have also the answers at the back. Okay, take it. So what are isotopes? What are the isotopes of oxygen? You just have to read the background information to answer the questions. And then we have the what is it? I have already discussed to you what are the common isotopes and their uses. Okay, now let's go to activity number 4 for this activity. So let's take for example xenon 133, which has 79 neutrons and 54 protons. The question is, how many electrons are in this isotope? Xenon 133. 133 is the atomic mass or the mass number of this isotope of xenon. 79 neutrons, 54 protons. The electrons is equal to the number of protons. That means the number of electrons is equal to the number of protons, which is 54. So again, the protons are the positively charged particles. The electrons are the negatively charged particles, while the neutrons are the particles with no charge. Protons is equal to electrons, but protons plus neutrons is equal to the atomic mass or the mass number of the element. For number 1, here are 3 isotopes of an element: carbon 12, carbon 13, and carbon 14. Actually, it should be written as C612, C613, and C614. The 12 is called the mass number of the atom. 6 is the atomic number. The atomic number is the same as the proton number and the number of electrons in a neutral atom. So for this case, the atomic number is equal to 6, which is also the same as the number of protons, which is also equal to the number of electrons. While 12, 13, and 14 are called the mass numbers. Okay. And mass number is equal to proton, the number of protons, plus the number of neutrons. Given this, we can also find the number of neutrons to be equal to the mass number minus the number of protons, given the following formula. How do we answer now the following questions? Letter A, the element is, for this case, the answer is carbon. The number 6 refers to, for this case, number 6 refers to the atomic number or the number of protons. Next, the numbers 12, 13, and 14 refers to the mass number. And how many protons and neutrons are there in the first isotope? Okay, so the protons is the atomic number. So the protons, the number of protons is equal to 6, since it's the atomic number, while the number of neutrons is equal to 12 minus 6, which is also equal to 6. For question number 2, how many protons and neutrons are in the second isotope? So the second isotope, we have 6 atomic number and 13 neutrons. So again, the number of protons will be equal to the atomic number, and that is equal to 6. While the number of neutrons will be equal to the mass number minus the proton, that's 13 minus 6, which is equal to 7. So that's how we're going to answer this letter E. And for letter F, okay, now you can do it. The number of proton is equal to 6. Oops, let me just correct this. This is equal to 6. Okay. While the number of neutrons will now be equal to 14 minus 6, which is equal to 8. This time, let's go to activity number 5, which is completing the table. You already have an example here, which is potassium 37. The atomic number is the same as the number of protons, which is also the same as the number of electrons. So here, if you have titanium, so that's 22 here, 22 with the number of protons, and 22 also to the atomic number. And these numbers here, 48, will be the mass number. Or if you add 22 and 26, you'll have 48. For uranium 238, 146, and 92, you have to add these two to get the mass number. That's 238. And the number of protons is 92. So the atomic number is also 92. And the number of electrons will also be 92. Okay? Now, let's move on. So, isotope name. What are the uses of your chosen isotopes? So, just find your isotope. Then, what you have learned. Okay? And then, for the problem solving, let's just try to answer number 3. Okay, I have already given you an example a while ago. But let's try to answer the number 3 here, which is a little complicated since there are a lot of percent abundances present for titanium, which has 5 isotopes. Okay, so let's try to work on that. Okay, for titanium, which is 5 common isotopes, let's try to solve this to find the average atomic mass of titanium. Okay, starting off with changing the percent into decimals. Again, let's just move the decimal point 2 places to the left. So the 8% will just become 0.08. Okay, multiply that to 46. Why 46? 46 is the atomic mass of the first isotope. We will add that with 0.078 times 47. You see the 47 there? It's the that's the mass number or the atomic mass, plus 0.734 times 48 plus 0.055 times 49 plus 0.053 times 50. So those are the 5 common isotopes of titanium. Okay, let's just put the equal sign. Count it again. 1, 2, 3, 4, 5. Okay, using our calculator. So we have 0.08 times 46 plus 0.078 times 47 plus 0.734 times 48 plus 0.055 times 49 plus 0.053 times 50, which is 47.923. This gives you now the average atomic mass of titanium, which you can also see in the periodic table of elements. 47.923 thousandths, or 47.923. So that ends the activities here in LAS number 5. Please do not forget to put your reflection. Okay, and that's it. So these are just the key to corrections for LAS number 5. We'll have the next module then. Atomic